Welcome to The Explainer. Today, we are diving deep into the body's incredible internal teamwork. We're going to see exactly how two of its most critical systems, the renal and the respiratory, work together to maintain the super delicate balance that keeps us all alive.
So, what do these three things have in common? I mean, on the surface, they seem totally unrelated, right? But here's the thing. They all throw the body's delicate balance of fluids, electrolytes, and acids completely out of whack. And really getting that connection, that's the absolute key to mastering this whole topic.
Okay, so let's start at the very beginning. We got to build the foundation of this balancing act, and that means talking about fluids and electrolytes.
At the heart of absolutely everything is this one big idea: homeostasis. You can think of it like the body's ultimate mission control center. It's always, and I mean always, making these tiny little adjustments to keep everything, your temperature, your pH, your fluid levels, in that perfect Goldilocks zone. Not too hot, not too cold, just right.
So how does the body pull this off? Well, it all comes down to two basic laws of physics. First up, you've got osmosis. This is all about water. Water's kind of a follower. It's drawn to where the action is, to the solutes, like salt. So it moves from a watery, diluted area to a more concentrated, salty area. Then you have diffusion. This time, it's the solutes themselves that are moving, spreading out from a crowded area to a less crowded one until everything is evenly distributed.
All right, now let's meet the two superstar players in this whole operation, the ones responsible for maintaining that balance: the kidneys and the lungs.
And I love this comparison because it perfectly shows their different styles. The kidneys, they're your master regulators, the slow, meticulous, long-term planners. They work over hours, even days, to carefully manage fluid, filter out waste, and tweak those electrolytes. But the lungs? Oh, the lungs are your rapid responders. They're the emergency first response team, making immediate second-by-second adjustments to the body's acid-base balance, just by controlling CO2.
So how do the kidneys do their thing? It all happens inside millions of these tiny little factories called nephrons, and it's this really cool three-step dance. First, filtration. They just filter a big chunk of the blood. Then, reabsorption. They pull back all the good stuff the body wants to keep. And finally, secretion. They actively push the garbage and waste products out into what will eventually become urine. Pretty smart, huh?
And of course, we need a way to check up on how well they're doing their job. That's where these lab values come in. Now, creatinine, that's your gold standard. It's the most direct look you can get at kidney function. BUN tells you about waste products, but it can also be a clue for dehydration. And urine-specific gravity? That's a fantastic little trick. It tells you how concentrated the urine is. The higher that number gets, the more dehydrated a person is.
Okay, let's switch gears to the lungs. Remember, their big job is controlling acid. So, what happens if your breathing slows down or isn't working well? That carbon dioxide, which is an acid, starts to build up in the blood. When that happens, the pH drops and the body becomes too acidic. We call that respiratory acidosis.
And as you can probably guess, the exact opposite can happen too. If someone is hyperventilating, breathing way too fast and deep, they're blowing off way too much CO2. They're getting rid of too much acid. That makes the blood pH rise and it becomes too alkaline, and that's respiratory alkalosis. Okay, so this is where it gets really interesting. The kidneys and the lungs, they're a team. They have each other's backs. So what happens when one of them starts to fail? Well, the other one tries to step up and pick up the slack.
Let's play out a classic scenario. Imagine our master regulator, the kidneys, just suddenly go offline. A patient is in acute renal failure. What happens next? Well, immediately, you have two very, very dangerous problems. First, the body can't get rid of all the normal metabolic acids from, just living, so the blood starts getting acidic. And second, it can't get rid of potassium. So potassium levels in the blood start climbing to toxic, dangerous levels. You get metabolic acidosis and hyperkalemia.
But the body is incredible, right? It's not just going to sit there and take it. It has a backup plan. It has a built-in rapid response system that's ready to jump into action.
And this is where that teamwork just shines. The lungs are rapid responder, sense that rising acid in the blood, and they immediately go into overdrive. They trigger these deep, rapid breaths to blow off as much CO2 as humanly possible. Why? Because CO2 is an acid. They're trying their best to counteract the acid that the kidneys can't get rid of. It's a brilliant, if desperate, attempt to get things back in balance.
All right, time to put on our detective hats. Let's take everything we've just talked about and see how we can use it to decode the clinical clues a patient's body is giving us.
So you're looking at the heart monitor, and you see this really specific, kind of scary pattern pop up on the EKG. This isn't just random static, people. This is the body sending out an SOS.
Those specific changes, those tall, pointy T waves, and that wide QRS, they absolutely scream hyperkalemia, which is high potassium. And as we just talked about, this is a classic sign of renal failure. It is a true emergency, because that high potassium can cause deadly heart rhythms.
Okay, let's look at another case. A totally different patient. This person's main issue seems to be neurological. They're confused, maybe a little out of it, and they've had seizures before.
This picture points us directly to hyponatremia, or low sodium. What's happening is that there's too much water in the body, and it's diluting the sodium. This causes water to shift into the brain cells, making them swell up. And a swollen brain leads to confusion and seizures. So what's our number one priority here? Patient safety, absolutely.
Now this next one is just a fascinating clue. You do a simple little physical exam test. You just gently tap on the facial nerve right in front of the ear, and suddenly you see their cheek muscles twitch all on their own.
That little twitch, it has a name. It's called chopstick sign, and it is a dead giveaway for hypocalcemia, or low calcium. When calcium is low, the nerves and muscles get super excitable and twitchy. It's just an amazing example of how a simple test can reveal a really complex problem inside the body.
So there you have it. The careful, meticulous planning of the kidneys and the lightning-fast response of the lungs create this powerful partnership. And once you really understand that team dynamic, you can stop just memorizing lab values and you can start actually reading the body's story. You can see the compensation happening, you can anticipate what's coming next, and you'll know exactly what clues to look for when that delicate balance is off. And that, right there, is the path to true mastery.